How's it going, my friends? I am so excited to be back here. Is this on? Am I good? Okay, they're giving me thumbs up. I'm excited to be here. How you doing, my friend?
I'm doing great. How are you?
Why don't you introduce yourself?
My name's Eric Boyd. I lead the AI platform team at Microsoft.
So the first question, obviously, and the most important that everyone has for you is, are the robots taking over, and how can we become their friends?
The robots are totally taking
Nice.
over.
Okay.
No, I mean that question is such a great one to get. I've gotten variants of that.
Can I hear some of these variants? By the way, please get your questions in because I'm sure I've gotten some really weird questions about AI.
You know, I was at an Onyx conference, and Onyx is the Open Neural Network Exchange. It's something we work together with Facebook on, and Amazon and NVIDIA, and invited the whole ecosystem in as a way to exchange, models from one format to another. But at a space, it's a file format.
Yeah.
And after sort of talking about Onyx, I got a question that was, well, have you ever had an Onyx model, like become self-aware? And I'm just like, it's a file format. That's really not how this stuff works. So it was, yeah, there's a lot of misunderstandings around what AI is, how it works, and what people can do with it. And so that's a lot of what we need to work through is AI can do some really incredible things, particularly in the areas of vision and speech and those types of areas. But it's not sentient, it's not self-learning. Like if you have an AI model that plays chess really well, it's not going to clean your floors.
No, I've tried, and it made a mess, and my wife got mad.
Yeah, I doubt it made a mess. I bet it didn't do anything.
It didn't do anything. So here's the question. For those that are out there that are like, because there's a lot of AI this, AI that all over the place. For businesses out there that are like, okay, I think I need to take advantage of this, where are some good opportunities to start?
Yeah, that's a great question. I spend a lot of time talking to companies about what are their opportunities and what are the things they can do. The great thing about AI is it really is touching and transforming each and every part of every business. And so even like the feature that we showed today in some of the keynotes, the IntelliCode, if you think about that, that's such a small feature in Visual Studio, right? Just reordering the way that the IntelliSense options come back. But they were able to make that better, and by using AI and having a predictive model that knows what am I likely to be using it for, they really made Visual Studio better. Now, how much better? 0.5% better. But if you can do 0.5% across all the different capabilities, you can make so much better. And so, I was talking to one company. It was a beer manufacturer, and I said, well, how are you using AI in beer manufacturing? And his answer was, we don't use it at all in the beer manufacturing. We use it in everything else, in logistics, in the supply chain, in predicting the inventory that we're going to need, and forecasting the prices we're going to pay. All the other capabilities that they had, they were using AI models in those areas of their business. And so really, that's what's so interesting to me is just finding each business and how it's going to transform each of their businesses, and really challenging companies. You need to have the creativity to figure out how are you going to actually make your business better? Where can AI really work for you? And really learning those different areas.
So what is a good smell? You remember code smells? I don't know where that term came out, but it's such a weird one.
I don't know that term at all.
Is a code smell is like you're looking at code and you're like, this smells like we could fix it or make it better.
Enough, sure.
Where are the AI smells, so to speak, in a business? Like, hey, maybe you should consider using this programming, because I consider AI a programming technique.
That's right. What are good cases for it? If you have something where you're applying some rules, like the sorting algorithm in IntelliCode, right? Someone came up with a rule that said, let's sort it alphabetically. You can almost always find an AI algorithm that's going to predict or do that better. Fraud detection is a classic place where people have rules. If we get too many requests from this IP address, it's probably fraud. AI is going to do fraud prediction way better. If there are, financial forecasts, I'm going to look at these 3 things about, the industry or the trends and sort of project what our finances are going to look like. AI is going to do that better. Insurance industry is getting completely redone. If you think about how insurance works today, they look at 5 different factors about your driving history or your car you have, or maybe your neighborhood. And AI can consider 10,000 factors effectively.
I see.
And so those are things where AI is going to do a much better job of predicting. And so, yeah, those are all things that smell like AI would do well in it.
So tell me about the requirement, the data requirement for AI. Like, because look, I've had people come up to me and be like, hey, just do some AI. And I'm just like, well, can you give me some data? Why is
Right.
data such an important element of AI?
Yeah, one of the first things I talk to companies about when I meet with them is if you don't have differentiated data, you don't have differentiated AI. So, what is the thing that you have that's special and unique about your business that's going to make your business and your product
Right.
better? And so, if a company's not collecting that today, and a lot of companies, I've talked to companies and they're like, oh, we throw all that data away. And you're like, that's going to be the foundation that you're going to build your models and make things successful from. But you've got to understand, what is that differentiation? What is the thing that you've got that's unique about your business that you can build a great data asset on and then build models on top of that?
So before you even start thinking about AI, you should probably think about saving your data.
Just making sure that, and saving, collecting, and really looking for places where you have data where you can tell this was a good outcome or this is a bad outcome, right? If you take insurance, this person defaulted on a loan, this person didn't default on a loan. So I can now use that to predict. Forecasting financials, I predicted very accurately based on this information, I predicted poorly here. The more you have those are the labels. That's the stuff that's going to feed into your model, and it's really going to, be the way that your AI algorithm is going to learn. And so if you have that, then you've got the foundation to do something interesting.
Awesome. So you're using the term a lot, model.
Yeah.
And for those that are maybe don't know what a model is, how would you describe what is a model?
Yeah, a model it's really just a system of predicting what's going to happen based on some inputs. And so, I mean, you can think of a really simple model. You can think of Scott Guthrie was talking about, I want to predict the price of a car. And so a model could be as simple as, I take the year that the car was, and I take the condition of the car, and I multiply it by 3, and that's the price of the car. That would be a particularly bad model.
Right.
An AI model is now going to take those same inputs and come up with a price based on how AI sort of learned. And so there are a lot of different ways you can represent models and think about them, but at a base, that's what a model is. It's something that predicts something.
Awesome. So we want all of your questions, so make sure you get them in, and I want to ask them. For those that maybe don't have a lot of data, and they want to do AI, how can Microsoft help?
So there are a lot of ways that companies can get started. There are a lot of use cases. It depends on what people are trying to do. If you look at their speech, if I want to add speech recognition to any application that I've got, how could I do it? Well, I could go and collect a whole bunch of speech people talking and transcribe that and then build a model that predicts that. Or I could use a cognitive service, which is going to do it way better than what they're already doing. So we have a wide suite of cognitive services that'll just really help accelerate people. You don't need anything to go and use a cognitive service. And you can do speech, you can do vision, you can do language, you can do search. All of these, right off the bat, you can go and get started with them.
Yeah, and it's really easy. I have it here on my screen. You can go to azure.com/cognitive. I think it'll go right to it. And like an easy one to look at is vision. Basically, I'm clicking it right here. And if you go to, for example, scene and activity recognition and images, you basically just upload your picture.
Yeah, it's really simple. If you have, you want to be able to identify the objects in a particular scene, just upload it and it'll sort of show you the different things on it. Then you can go further with that, the custom vision service, and you can say, everyone's favorite example, do you watch the TV show Silicon Valley?
Not yet, but I will. Hot dog or not hot dog? Is that the one?
Hot dog, no hot dog. This is a classic app. It's a really funny part of the movie or the TV show. You can build that I built it in 2 hours, but that's because I'm not a great programmer anymore. I used to be.
What happened?
I got old.
Yeah.
I stopped programming is the main thing.
2 hours though to build a hot dog, not hot dog?
And it was really very good.
Did you use cognitive services?
What I did is I used the custom vision model.
Okay.
And so I went to Bing and I searched for pictures of hot dogs, and I found about 20 of them, and I put them in there, and I searched for pictures of things that weren't hot dogs.
Nice.
And there's your classifier, and it really was very straightforward to go and build.
Awesome. So here's some questions coming in. Does Microsoft AI support self-training classifiers?
So
I think we do with auto machine learning.
So
Automatic machine learning will do that.
automatic machine learning is, so I guess it depends a little bit what they mean by self-training classifier. Automatic machine learning is going to do a lot of that. What automatic machine learning does is you basically would specify, here's the data set that I have, and I don't know, do I need a support vector machine? Do I need a neural network? Do I need a logistic regression? I'm not an AI expert. please just figure out the right model for me. And so automatic machine learning is going to do that for you. And so that's available today. You can get that as part of Azure Machine Learning in the SDK. It's one line of code, and it'll go and build you a model just based off a data set.
I have the line of code actually right. I'm scrolling. Here it is. It's literally, oh no, that's the deployment, sorry. That's this, here it is. It's the auto machine learning.
Yep.
It's actually 2 lines, but because one, you define the problem, and to run it, it's actually 1 line.
Right.
It's actually really nice.
It's really straightforward, really simple to use, and we're finding a ton of customers who are using this, and it really broadens the scope. There are really 2 ways I see people using it. One is, if you're a data scientist, there's a lot of tedium that you go through in trying, let's try the support vector machine, let's try a learning rate of 0.1 and trying to change all these parameters. Now you can just sort of say, just give me a model that's pretty good.
Yeah.
And automatic machine learning will just go and do that. The other class of users are people who don't even know what they would need to do. And they can, if I'm a developer, but I don't know how to do machine learning, I can use automatic machine learning and get a model just from 2 lines of code.
So let's see if I understand. So basically, you have a bunch of data.
Yeah.
I usually I think of Excel because it's the canonical. I say Excel, and everyone's like, oh, I just pictured a row, like a bunch of square of data. And you say, here are the columns I want to use to learn. And then here's the column I want to learn. You feed it in, and then it does it.
And it's funny you say Excel, because in Power BI, we announced this as in preview, that it'll be integrated as a wizard where you can walk through the experience doing exactly that. And so create a model just from saying, this is the column I want to predict, and here's the rest of the data that I've got.
And that's pretty amazing. I mean, if you look at the code right here, hopefully we can go to the screen, you can see that there is this data script that's basically says get data. And in there you define, and you can see my get data script right over, let me go here real quick. Get data script right here is basically saying, here's the X and here's the Y you want to learn. You give it that, and then it says, I'm going to run a bunch of models.
That's right. It goes through, it tries all the different models. It's really great. It gets a little meta. It is a machine learned model that predicts which machine learned model is going to work best on this set of data. And the more you use it, the more you use it on your sets of data, it actually learns from the history of how it's gone and predicted, and it gets better because it has a great answer of like, well, how well did it predict against the test set? And so the more you use automatic machine learning, the better it's going to work for your data, the better it's going to work for you, which is really pretty neat.
And the cool thing about this, and this is the meta bit, like it's using a recommendation algorithm. So basically like your shopping cart, when you go shopping online and it recommends other products, we have that AI when you run a model and it says, oh, it did okay. It starts to recommend others and it runs them. It's pretty cool.
It's the same idea. It's not necessarily the exact same implementation, but it's the same idea as that. Yeah, really cool, really simple to use. And I think, honestly, going forward, I think more and more stuff is going to start fitting into that automatic machine learning paradigm. I think you're going to start seeing image classifiers work that way. All the types of things that you're doing today, more and more of it's going to fit into automatic machine learning. And that's really our goal, is how do we simplify this stuff? Because there's so many people now who the demand to have a machine learned model, the number of people who want it, the demand for AI is really high. But there aren't enough people who can go and develop it. And so how do we make it simple so that any developer can go and build and have an AI model? You have developers today, if you think about, I use the analogy of a hash table. Developers use hash tables without even thinking about it, right? They probably learned about it in college and they studied what's a good hash function and things like that. No one's ever actually implemented that. They just use a map and they just call it.
Right.
How do we get that, machine learning from the days where it is today, where you kind of need to be an expert in linear algebra and calculus and back propagation, to know this is a space, here's my data, push a button and go do it. It's coming, and we're going to get there.
But you know what? It's still okay to learn linear algebra calculus because it is dear to my heart. Because I'm a nerd at heart. I'm not wearing my glasses, but if I was, you would see. Love calculus.
Well, and this is what you're seeing a lot of people doing. Everyone who's a developer out there today is learning more and more about how to be a data scientist. Cool. And much like the hash table, understanding the fundamentals is really going to be important to doing it effectively.
Awesome. So it looks like Tony from Brazil is watching. We want to say hello to you, my friend. I have an idea in mind to build a face recognition for my business. Customer comes, profile loads for receptionist. Can Azure help me with this?
That's a great question. So we have the Cognitive Service, the face recognition API, And so you can absolutely go and do that and have it recognize your customers and suggest a profile of it. I think it's, it's really great idea, right?
Yeah.
A customer walks in and you say, oh, they typically order, this particular cup of coffee or something. You can start getting it ready as soon as they walk in. And so for your regulars, what a great experience, right? I'm coming back to that restaurant every time because they're going to be ready that much faster. They see me coming.
And that's amazing. Like just with computer vision, it will tell you the box around the face.
Right.
And then you can use and chain that together with custom vision with faces of your customers. And so you get the face box, you take the box out, and you give it to custom vision, and now it'll tell you.
That's right. You can build up the profile and the history over time. And so I think it's a really interesting use for how facial recognition. There actually already are coffee shops in China that do this.
Really?
And so absolutely. You walk in and they recognize you and they get your drink already. So I think this is going to be coming more and more.
Awesome. So a follow-on question, but do you have an auto classifier where the data does not have predefined data, so the auto classifier would group similar things? I mean, that's a really good question. Like, look, I'm an engineer, and most people don't know this, but I'm like an AI person.
Yes, you are.
And so, like, right away when you say group things, I'm thinking like k-means or hierarchical clustering or Gaussian mixture models. So there's already ways to do that.
Yeah.
But we have the compute to do any type of machine learning model. Tell us a little bit about Azure Machine Learning Service and what that is.
Sure. So, you talk about you need access to the compute to go and train your different models. That's one of the, why is AI really taken off? It's been three factors. First is the amount of data that's available.
Right.
The advent of big data and products like Spark and Azure Databricks, and now you can use those to really manage your large data sets. The second you alluded to is compute, and it comes in two different ways. One is it comes through GPUs, which have really accelerated the amount of parallel computation you can do on things, particularly matrix multiplication, as well as the cloud, where these GPUs are really expensive. And if I need 20 or 100 of them, I don't want to have to go buy them because I probably only need them for a few hours. And so the cloud ability to go and use all that compute, for the time that I need and only pay for what I use has really transformed it. And then the third thing is the new algorithms, coming up with, deep learning and convolutional nets and things like that has opened up a whole host of applications. And so with Azure Machine Learning, what we're trying to do is bring that together and make it really easy for you to consume. And so, we do it through a Python SDK. So you can be in an Azure notebook or a Jupyter notebook or in VS Code or in PyCharm or whatever you like to use. You're right there in your notebook, and you can get access to start training locally, change one line of code. Now I'm accessing a whole host of resources on the cloud, and managing the data that's stored in basically any way you can store it on Azure Data. Everything from Azure Data Lake to CloudDB, everything is all out there. Cosmos DB.
Awesome.
So yeah, it's all really simple and integrated.
So we started with, if you want to just get started quickly, you should use Cognitive Services.
Yeah.
If you want to customize a little bit, we have some custom versions of Cognitive Services. We mentioned Custom Vision. There's also others. I think you can upload your own acoustic and language models for speech.
That's right.
You can use Lewis to start to tag your own data and so there's easy ways to enter. But let's talk now to those that maybe are more advanced that are starting to use like scikit-learn or PyTorch or TensorFlow. Can you tell us what the current development process is like and how Azure Machine Learning Service can help?
Sure. It's interesting the progression you walked with. We think about it as cognitive services are, Microsoft's model, Microsoft's data. The custom services are Microsoft's model with the customer's data. And then when I want to get to a custom model, well, then it's the customer's model and the customer's data.
Right.
And so, how do you do that? If I'm building a model, frequently what I'll do is I will come up with the set of data that I have that I think has the best features in it. And I'll come up with the algorithm that I think I'm going to use, and I'm going to go and train it. And then we call that an experiment. And I go and run, and I compare that experiment against the history that I've got, the test data that I've got. And I see how well I performed. And what you find people doing is this iterative loop over and over where they keep changing. Maybe I need some more features, or maybe this feature is going to make it predict. In my car example, maybe the year is not very interesting, but the location, the zip code is, or something like that. What features can I add in? And so Azure Machine Learning will keep track of all of the experiments that you've run so that you can see which one actually performed the best and basically keeps the history of what did you do different each time that you had it. And then when I have a model and I'm ready to sort of deploy it, then the Azure Machine Learning will put it in the model registry. And so now I can keep track of all the models that I've got. And as I deploy them, I can understand where each model is in its life cycle. Is it deployed in which different systems? And so I can manage that deployment and management of them much, much simpler. There are a couple of other capabilities that I think are pretty interesting. I talked about sort of the life cycle of I'm going through all these different experiments. A lot of times what I want to do is what's called hyperparameter tuning.
Right.
For each of these models, there are probably a dozen different parameters. The learning rate, the number of nodes in each level, all sorts of different things. And so hyperparameter tuning is a way of helping you select the best ones without having to sort of painstakingly iterate through them all yourself. And so you put all that together, and it dramatically simplifies the machine learning developer, the data scientist, in getting their models developed. They become much more productive. We talk to people who, have spent weeks training a model, and
Right.
now they're like, we can get this done in a day. I can do this much, much faster.
And the important thing to note is that, like, look, generally when I'm running these things, I usually run it on my machine, and then my machine is tied up. And then I try to get someone else, and I'm using PyTorch 0.4.197,
Right,
and
right.
and Sally's using PyTorch 1 preview because she's all way more advanced than I am. And it's hard to get all these things to match up. How does Azure Machine Learning help people that work in teams and data science teams? What is it about Azure Machine Learning that will help people work together?
Yeah, I mean, there are a couple things you can look at. One is you mentioned like my machine's all tied up. That's the beauty of the cloud, right? Is I can now use extra computation on the cloud. I can put it in a data science VM. I can put it on the training modules, a whole host of GPUs, and have sort of complete access to my machine. The other is really the reproducibility.
Right.
I can take sort of each model and I can sort of run it the exact same way that you ran it. And so yeah, you mentioned the different versions and all the different things that I'd need to do. Makes it much easier to sort of say, hey, we're all sort of working on the same thing and share the code and really stay aligned with it. And that's something that we've learned internally. We have on our internal services, thousands of developers working on the same model in Bing. And how do you do that effectively? How do you have 1,000 people try and make improvements to a single model? You have to have all this infrastructure. And so as we've learned from Bing, all of that infrastructure that we built is coming through Azure Machine Learning, and that's what we're deploying in Azure Machine Learning, all the things we've learned and making that product much better.
Awesome. Well, keep your questions coming. Obviously, any AI questions that you might have, we want to get those in. So there was announcements regarding AI today. Can you tell us about those?
Sure. So a couple announcements that we made. First and foremost, Azure Machine Learning is generally available. I'm really excited about this. We've had a whole bunch of customers try it in preview, and their feedback has been really, really great. They think the direction that we're going with it has been fantastic. We feel like the quality of the service, the quality of our documentation understanding is all great, and so we're happy to announce it as a generally available product. And with that, all the things that come with it, automatic machine learning, which we've talked about, is generally available. The hyperparameter tuning, the experimentation capabilities, the model management, the ability to deploy, all of that service generally available and something that people can go and take and use, which is really exciting. Another thing that we announced today is the Onyx runtime. So I talked a little bit about Onyx at the start. Onyx is this file format for exchanging models and for really making it simpler for hardware manufacturers to optimize them. One of the challenges that hardware manufacturers talk to us about is they say, look, I've got TensorFlow, I've got PyTorch, I've got Chainer, I've got PaddlePaddle, I've got Caffe, I've got all these different frameworks, and people expect me to optimize each and every one of them. How do I do that simply? And Onyx says, hey, you can just sort of make this an Onyx model. They can all convert into Onyx, and now you can optimize one of them. What the Onyx runtime is this is the same runtime we've been using in Windows and Windows Machine Learning. It's now available open source. It runs on Linux. It will run on Windows. And it runs dramatically faster than sort of the native implementations. And so we've seen internally, virtually every model has run faster. Some have, the average is probably around 2 times faster. But some have been as many as like 7 or 8 times faster. And so this is available. It's open sourced, and people can go and get it. I'm really excited about that as well. Another thing that we announced, the third sort of major area, is around cognitive services. We are the only company that does containerized cognitive services. Right. People want to be able to run AI models, and they don't want to just consume it in the cloud. Sometimes they have latency requirements, or they have intermittent connectivity for some machine that they're trying to run it in. And so they want to be able to take the model and run it on-prem or on the edge.
Right.
And so we announced containerized models, and today we announced that the language understanding model is also available in a container.
Amazing.
Yeah.
So Lewis.
Lewis is now available in containers. So
That's amazing. I was recently in New Zealand, and one of the hospitals there, they wanted to use cognitive services to do OCR,
yeah,
but they couldn't do it because they could not, the records could not be uploaded to the
Yeah.
cloud. This really enables them to start to do that work.
that's exactly one of the use cases we see is, regulations prevent them from moving the data. And so being able to bring the cognitive service directly to where they actually have the data opens up all kinds of doors that previously they couldn't do before. And so we have had a ton of positive feedback from customers on it. People are really excited about this. So I'm excited to see that going out.
It's basically the first ever lift and shift down that I've ever seen.
Yeah, it's interesting. All the, everyone is trying to lift and shift up to the cloud. And look, that's an important trend because the cloud offers a lot of advantages. But as a company, we've been very committed to the hybrid and making sure we work with people where they need to be. And often that means, hey, some of the things we've done in the cloud need to happen on the edge. There are real legitimate requirements
Absolutely.
for why that needs to be done. And so we want to make sure that that's supported.
Like just basically, and here's a really silly use case that I thought of. If you run a parking lot and you want to have an unattended parking lot and still charge people, you can have a local model taking picture as cars drive in with OCR getting license plates.
That's right. All sorts of examples like that where, we hear of companies that have manufacturing plants that, their connectivity comes and goes, right? They have vehicles that they want to drive out into the field that they might not have any connectivity at all. And so to be able to still run models locally, there's a lot of great examples with drones. They want to fly drones along power lines and sort of see, hey, are there defects in the power lines and things like that, things they need to go repair. You could have someone drive for thousands of miles. You could fly a drone and have it take pictures and say, this is where you need to go to.
That's awesome.
And so, yeah, it works great.
So here's a couple questions. Will ML.NET expand to training framework so I don't have to learn Python, NumPy, TensorFlow, PyTorch, and I can rather stay in C# where I feel at home?
So ML.NET has a whole host of algorithms where you can train models directly in C# in ML.NET. ML.NET, again, grew out of internal technology that we had where a bunch of internal developers used C# and wanted to have a good framework for developing their models in C#. And so we've wrapped it up and made it ML.NET as something that now you can go and train models in C#. We have a ton of developers in C# that are really not well served by the ML community because the ML community says everything has to be in Python.
Right.
And so being able to have ML.NET as a way that you can now stay in C# is really pretty interesting for people. And, there's still a ton of activity happening on Python, so I wouldn't necessarily discourage you from learning Python because that's where there's a lot of value being created. But absolutely, ML.NET's going to let you stay in C#.
Awesome. Next question. AI is more than just image recognition. What about searching for text and dynamic images? Current OCR engine is not accurate and cost per transaction forces us to use on-premise solution.
Interesting. So I'm not really sure what they mean about not accurate.
Or dynamic images.
Yeah, I mean, maybe in videos or something. I mean, so the OCR solution that we have, I get benchmarks on all of our cognitive services on a weekly basis. We're beating everybody else with OCR. So I believe we have the best OCR solution that's out there. It really performs quite well. And, we have, I talked to our researchers, they are very proud of the techniques that they've used, some of the tricks that they've done in their models to make it really perform so well. Additionally with images, you sort of talk about finding different things within the image. I mean, I loved the example today that you had in the NBA example, showing really the face detection working on all sorts of small areas. There's also logo detection, right? And being able to find the logos in all sorts of different places in it. And one of the places where we really pull all this together is in knowledge mining.
Right.
And so you take exactly what you were doing, and now you're extracting all this information from across an image, and some of it is OCR, some of it is looking for text in an image, some of it is face recognition on the image, some of it is sentiment analysis on the image or on the text or whatever it is, and building an index that's now searchable and brings all the, the named entities that you can sort of think of, whether they're people or places and what's the relationships between them. You can bring all that together, and so knowledge mining makes that really powerful.
Now, and I will say, for you that submitted this question, like if it's not working for you, can you email me and I'll look at it because I've seen our OCR engine get like words behind chain link fences that say stop that are crooked and give you the right bounding box. It's ridiculous.
I've even seen it. There's you love the blacked out text where they used a magic marker and you can still kind of see the text underneath of it. And our OCR is telling you what the text is underneath of it, which is really very cool.
It's amazing. Okay, so tell us a little bit about some of the exciting things that you see some of the customers doing, because one of the problems with this technology is people have a hard time like saying once they get it, they're like, oh, okay, I can see how this works.
Yeah.
But they have a hard time seeing where it might fit in their business. What are some exciting things you're seeing customers do?
You know, there have been a lot of interesting examples. You know, one of the things maybe more fun ones is, you know, we've talked to Shell, and so Shell has gas stations, of course, all around the world. And so they put cameras in their gas stations. And what they really want to detect is fire, which is a big problem at a gas station. But what they also are detecting is the person who's filling up with gas, is he smoking? And if they are, they want to alert the attendant and say, hey, go yell at that person, tell them it's really dangerous to smoke at a gas station. And so lots of applications like that. We see a ton of image classification applications. Companies, you know, Jabil is looking, they manufacture chipboards. And so the last step, they wanted to sort of take an image of it and see, do we miss any of the solders in it? Is there any defects we can see with this? And so just improving the quality that they have there. We see a ton of bot solutions. People are looking for bots, you know, often in customer support. Can I deflect, you know, 20% of my customer support costs and save myself $20 million while giving my customers a better experience? We see virtual assistants where people want, you know, their branded experience, their voice, you know, sort of interacting with a customer in a virtual assistant way. So we see a lot of solutions there. So yeah, just a ton of applications across the board.
Awesome. So we have a question coming in. How could I use AI to help with accounting, such as invoice coding?
So I'm not an accountant, and I'm not entirely sure what invoice coding is, but I'll guess.
Okay.
You know, presumably, it sounds like a classification problem, right? I have an invoice come in, and I need to decide which budget do I charge it to, or which type of invoice it should be, or anything like that. There are a number of different ways you can do it, depending on sort of how your invoice comes in. One is you can do image classification. If you have an invoice that sort of looks like image one or an image and something else that looks different, you can do it that way. The other is to build sort of text classification and sort of understand what type of system this is. But that's a standard classification problem. And that's the exact example of what I'm talking about of each business and each industry needs to find the ways that things are changing for them and how they can really use it to make their business better. Where, you know, if you can speed up your classification on your accounting invoices and have better accuracy with that, you just get so much acceleration from that as a business. And so really finding those ways that really getting the industry to have the creativity to understand what are the places they should be using this technology. That's going to be one of the most exciting things over the next few years.
I found early in my career as a programmer, anytime someone wanted me to optimize something, I would look for tasks that someone repeated exactly the same way often.
That's right.
Now I feel like when I'm doing AI, my particular smell is if someone is like altering code like 0.7 to 0.5 or adding extra if statements and then deploying.
Yeah.
Like for me, when you're doing those kinds of tweaks where you feel like you need to take a shower afterwards as a coder, that's a good place to start thinking about using AI.
They're using rules to make a prediction.
Right.
That's what you're sort of describing. Should it be 0.5 as a threshold? Should it be 0.3 as a threshold? And you know, this is where I say you saw this in fraud a lot. If I get 1,000 requests from the same IP, it's probably fraudulent. And you know, I remember in the early days when I was working on fraud, you know, AOL dial-up modems were a huge long I've been working on fraud, because they all came from the same IP address, and so you'd shut down all of AOL from that one IP address.
Nice.
And an AI model is going to be much better. It'll learn that, hey, there are different patterns that I should be looking for, and so instead of having these broad course rules, I'll have these. You know, I can really pull in 1,000 different features in and build a model around that.
Let's talk a little bit about sort of the elephant in the room, and this is important because people are looking at this and they're like, hey, how much is this going to cost? If I want to build my own machine learning model and Azure Machine Learning Service, is this going to cost me a lot?
So the beauty of using the cloud is that you use only what you consume.
Right.
And so the cost for GPUs, if you were to go out and buy a whole host of them, they're tremendously expensive. And so the rates that you can use when you're using the training service, is measured in, the tens of cents per hour and things like that. So dramatically cheaper. Building models, yeah, there's costs associated with it, but it's not exorbitant. This is something, and the benefits that you get from it on the other side, I don't think I've seen anyone come back and say, hey, we're not going to build this model because the training costs are too high.
And here's the thing, like I've laid down an Azure Machine Learning Service workspace, and we basically lay down 4 things. We lay down App Insights, which is nothing.
Yep.
We lay down storage, which is empty.
Yep.
Right? We lay down ACR, which there's a free version.
Yep.
Right? And then we lay down, so App Insights, Azure Storage, ACR, and there's one more thing that I'm forgetting. App Insights, Azure Storage, ACR, and there's one more that'll come to me at the end.
Compute batch.
Yeah, oh yeah, the compute. Yeah, the compute stuff. And even the compute isn't laid down until you specifically ask for it. And so you can also create a compute environment that has 0 to n nodes.
Yeah.
And it won't even run.
Yeah, I mean, that's, honestly, I don't know how everyone doesn't develop in the cloud these days. The economies of scale that you get from being in a cloud are they just give you such a better efficiency from that.
Mm-hmm. It's pretty amazing. Okay, so we've got about 3 or 4 minutes left. Where can people go to find out a little bit more about this AI stuff, and how can they get started? Like if you're a programmer and because you already know all about all this AI stuff, what would you suggest someone go do right now?
I mean, the easiest way to really get started is to go and look at the Azure Notebooks and start with there. The Azure Notebooks will walk you through how to use Azure Machine Learning Service. Notebooks are such a great environment for learning in because there's a description of what you're trying to do right in line with the cell that executes the code. Right. You can change the code and continue to execute it and make it just go right there in line. That's the thing that I would recommend everyone go and do. It'll both, depending on sort of what you need to learn. If you need to learn how the services work, there are great notebooks sort of walking you through how to use the service. If you need to learn how to build AI models, there are notebooks that'll show you, right. Hey, here's some of the simple AI models. Do I want to do the classic MNIST? I can draw a number and sort of have it recognized. Those are really straightforward ways to go and do that.
I just remembered it's Key Vault is the last one. So there's 4 things we lay down: storage, App Insights, Key Vault, and Azure ACR, right? Which is Azure Container Registry. Okay, so I figured I'd show just a little bit of what this looks like, because a lot of you are probably wondering what this looks like, and it's really simple. And the cool thing is that the part that maybe we haven't seen, and Francesca showed that a little bit during Scott's demo, is we actually have these amazing integrations into Visual Studio Code where I can go in and submit experiments by right-clicking, right, or view experiments or attaching, right? And that's the coolest part, right? And the other thing that I really liked about this that I've used so far is there's a team of 4 or 5 of us that work on these models, and all of us can see what all of us are doing.
Yeah.
Here's an example that you talked about, hyperparameter tuning.
Yep.
It ran 20 experiments, and notice that here there's this green line. It actually stopped running it because it's this one didn't work. This hyperparameter is not working. And that's cool because initially, usually I'm running a for loop and spanning over hyperparameters like the learning rate or momentum or whatever. Yep. Here, it's a smarter for loop because if it's within, and I use the bandit method, if it's within 20%, it's going to kill it.
No, and that's a great example of, usually you'd have to sort of be sitting there and watching and tracking, having it basically printf, hey, this is the learning rate, how it's converging. Hyperparameter tuning is just going to do that for you. And so it's really saves a ton of time for you.
And the other thing is, and this is the part that's really cool, here's all the compute environment you can see on my computer. We have some batch AI, we have some Kubernetes services in our compute, and it's basically we just submit and forget, and then we can see all the output. It shows us all the output in notebooks. It's amazing. Now here's the part that we were talking about. Models, to me, are the executable part of AI.
Yeah, that's right.
It's like when you compile your code, you get this assembly. I feel like that's what a model is too.
It's a great analogy.
You put something in and something comes out. And as a programmer, it's something that we want to version.
Yeah.
And in here, you can see we are versioning all of the models.
That's right.
And then we can marry models with scoring files to create images. And then we can do deployments. And so, for example, you can see this simple MNIST service right here. I wrote a cheesy little app here where I submit, I can draw a number. This is the cheesiest version. That's the easiest thing, but you can see it returns things from
Yep.
me directly from the service. And then I'm going to make like weird numbers, and you can see that, oh, it really thinks it's a 4. But if I start to do crazy things like this, you can see that it's going to start to be sure about other things.
Right.
And it's pretty cool that you're able to go from idea to submit a job to save a model to create an image to deployment, all within the same environment.
Yeah, I think it's really important. The software development lifecycle for models is different than for software.
Oh, it is.
And so understanding what are the tools that I need and how do I really use that more effectively, those are the things that are going to make you productive and successful in building your models and deploying them. If you try and do it, sort of the standard software way, you're going to have a hard time sort of figuring out how it all fits together.
Awesome. Well, anything else to finish up with, my friend?
I'm really excited that Azure Machine Learning is GA. I think there's going to be a ton of amazing uses for it, and I'm excited to see what people will do with it.
Well, thank you so much for being with us, Eric. All right. Well, the show is not over. We have my amazing colleague, Brian Benz, just over there with Beth to talk all things Java. Let's go to that.